Good day and welcome. Today we're going to start on chapter 7. This chapter is focused on triangles. We'll be discussing two special lines of triangles. I will teach you about some special quadrilaterals. And the toolbox you created in chapter 4 will be expanded with more tools. So let's start the intro and here we go. In chapter 4, I already told you what the perpendicular bisector and the angle bisector are. In this video, I will help you with two different lines in a triangle. We start with the median. The median is a line that splits the triangle in two halves with equal size. Equal size, not the same shape. To draw a median, you first need to find the middle of a side. Then draw a line from the middle to the opposite vertex. So this is the median from vertex C. When you've drawn a median, don't forget to add the necessary symbols. As point M is in the middle of side AB, we add these equal signs on the side. When you draw multiple medians in the same triangle, make sure you change the equal signs slightly, just to show which sides are equal. When done correctly, all three medians of a triangle should intersect in one point. This point is called the centroid. Centroid is used instead of center of gravity, as the centroid of a triangle is the center of its mass. By finding the centroid of a triangle, you can balance the triangle perfectly on the tip of a pin. This can be translated into the following situation. This triangle is a garden in the city center. The mayor of the town wants to fill it with different kinds of flowers. He has chosen for red tulips, yellow roses, and blue violets in an equal ratio. It is the designer's job to figure out how he can arrange the flowers in such a way that each flower gets the same area in the garden. And as the designer is a fan of triangles, he wants to incorporate that into his design. One way of doing this is with the use of medians. By drawing the three medians of the triangle, the designer can create triangles each with the same size. The mayor can then decide which triangle gets which flower. Next up, the altitude. The altitude is a line from a vertex perpendicular to the other side. This line is also called the height of a triangle. This is triangle DEF. To draw the altitude from vertex F, draw a line straight down to the base. This line is now perpendicular to line segment DE. To draw the altitude from vertex D, you have to make sure to draw the altitude perpendicular to line segment EF. So get your protector triangle ready and draw a perpendicular line through vertex D. Take note that the altitude is not the same as the perpendicular bisector. Both of them are perpendicular to a line segment, but the altitude goes through the opposite vertex, while the perpendicular bisector goes through the middle of the line segment. Side note 2, it is possible that the altitude and the perpendicular bisector are the same, but then we're talking about the isosceles triangle, and for sake of argument, we're not going to work with them in this paragraph. When you draw all three altitudes of a triangle, they will also intersect in one point. This point is called the orthocenter. It is possible for the orthocenter to be outside the triangle. When working with an obtuse triangle, two altitudes will be drawn outside the triangle. To draw the altitude from vertex R, it has to be perpendicular to side PQ, which means you have to extend side PQ. The same goes for the altitude from vertex P. These altitudes will then intersect outside the triangle, causing the orthocenter also to be placed outside. Although the orthocenter doesn't have a practical meaning, being able to find the altitude is an important skill to acquire. That's because the altitude is needed in calculating the area of a triangle. But more on that in chapter 9. And with that, we finished the first paragraph of chapter 7. In the next video, I will teach you what the three special triangles are and their properties. I hope to see you in the next episode. Bye bye!